all the different types of equations. We've graphed equations, we've written equations, we've done the parallel perpendicular equations. And today we're going to talk about function notation. So we're going to call this one Intro to Function Notation. And essentially this is the same as writing an equation, okay? Now we're going to see other equations and other graphs of things today as well. But when we do function notation, it's just another way of writing out a function. First of all, we're going to have a little bit of vocab, and then we'll talk about lots of different ways to write function notation and what makes a function a function. Well, first of all first vocab word is a relation. A relation is any set of ordered pairs. I can give you that set of ordered pairs lots of different ways. I can just list out a bunch of ordered pairs. That would be pretty straightforward. I could give you a table, like an XY table. Eventually, we're going to look at what we call a mapping, where we have like a bubble and we have some numbers, and then these numbers, and then you'll have like an arrow going to another set of numbers, which will be like your Y values. I'll show you what that looks like. I could even give you like a graph and plot a graph and have a bunch of points. That could be another way that we could represent a relation. So a relation could be given to you a lot of different ways. The domain is what we call the input. And because this is what we use typically, I'm going to say it's the set of x values. It doesn't always have to be x, but it's the first number in the ordered pair. And we're going to find domain a lot of different ways. We're going to find domain off of a set of ordered pairs or a relation, or we're going to do it off of a graph, but we're going to be asked to find domain a lot of different ways. And for those of you that go on to college algebra after this, then domain is like one of the biggest topics that we'll talk about throughout college algebra. And we find domain of a lot of different functions and a lot of different graphs, and we do a lot of stuff with domain. So that's something that you're going to see a lot of in any math class you take from here on out. And then the range is what we call the output. And it's going to be your set of Y values. So to kind of like think about what's going on here, if I gave you an equation of y equals 3x plus 2, then I could plug a number in for x. Any number I want to, and then I'm going to get the y value. So the input is the number that I'm putting in, right? You choose a number to put in for x, I figure out what the output is. So it's kind of like you put something in, you know, like if I were to put something in an air fryer, right, it's going to come out a little bit different than what it was, right? The reason we put it in is to cook it or to make it so we can eat it. And so that's kind of the same thing, right? You put something into a machine, you get something out of it. And so whatever I put in is going to look a little bit different when I pull it out. And so an input output is what we're talking about here. And then the last vocab word is what we call a function, and that's going to be like the purpose of everything that we do today. I'm going to give you the actual definition of a function, and then I'll give you an easy way to remember it. So each value of the domain is assigned exactly one value in the range. The way I like to say it, though, is the x value cannot repeat. That's quicker and easier way to kind of tell yourself of what we're looking for. Okay, this is the actual definition, but this is kind of a question that we're going to ask ourselves. If any of the x values repeat, then it will not be a function. Okay, and so you're going to have some questions today where it's going to ask you, is this a function, yes or no? And you'll have to say, yes, it is a function, or no, it's not a function. And we'll talk about some different ways that we can determine that. Okay, so those are the definitions that we're going to talk about. Hey, the first couple of things that we're going to look at here is they're going to ask us this question: is this a function? Okay, and in order to do that, it kind of depends on how the information is given to us. If we start with a graph, we're looking for a simple yes or no here, okay? And if I were to put up a parabola. Parabola is a graph that we've seen before. It's the graph of a quadratic function, and we'll talk more about quadratics later on in the semester, but for right now, we're just looking at the graph, okay? And sometimes we may have to put it into our graphing calculator. But in order to determine if this is a function, all the x values have to be different, right? Well, like for instance, this x value would hit the graph right here. This x value would hit the graph right here. And so all of my x values are different, and the easy way I can do that is what we call the vertical line test, which I think you guys have heard of before. If I take my pen and run it across this graph and I stop it at any point in time on that graph, I should only be touching 1 point. So if I stop it here, I'm touching 1 point. If I stop it here, I'm touching 1 point. If I'm touching more than 1 point on that graph, then it would be a no. Okay, so for a graph, we simply do the vertical line test. And so we would say yes on this one. As I move my pen vertically across that graph, I only touch 1 point at any given time. If I were to give you a graph that looks like this, say it's kind of like an oval. If I stop my graph right here, I'm touching 2 points, okay? One here and one here. And if I draw like a vertical line right here, because I'm touching 2 points at that given vertical line, then it would be no. So that's what we're trying to determine. So they're going to give you some type of graph, and we just have to look at that graph and say, does it pass the vertical line test? If it does, it's a function. If it doesn't, we say no. So it's a simple yes or no question, but just trying to understand why and how we can decide that. So if I'm given a graph, that would be the easiest way to do it. We may not know any points or ordered pairs from that graph. If I'm given a table, the question that we're going to keep asking ourselves, okay, you could put it on a graph if you wanted to, but this one is not graph. This one is just given to us as a table. And the question that you're really going to ask yourself is, does the x value repeat? We don't care about the y value, okay? The y value has nothing to do with if this is a function or not. All of my x values are different, so if that is the only points that are in this relation, then we would say yes, it's a function. If I plotted them, okay, 0, 4, 1, 5, 2, 6, and 3, 4, if I plotted those 4 points, then it would pass the vertical line test. There would not be 2 points on the same vertical line, okay? And so if you wanted to graph it, you could, but it's not necessary to graph it. In this case, the 4s repeat, and so we would say, no, this one is not a function because 4 repeats. So we have an x value that repeats. So the x value is the big thing that matters. We don't even have to look at the y values. Hey, they're going to give you some different scenarios, and I'm going to show you one that's a little bit different, okay? Kind of along the same line. Let's say that we have a golf tournament, and I know some of you may or may not know how a golf tournament works. Let's say the golf tournament is giving out first, second, and third place. Just make up some guys' names here. Oh, we got to throw Tiger in there, right, if we're talking about golf. Of course, Tiger is kind of out of the loop anymore. And I don't know, what's another name you guys want to use here? Todd, huh? Todd the golfer. Okay, and this one it's kind of weird how it's set up, right? Because we've got these places and we've got these things. Well, in a golf tournament, as you may or may not know, okay, you can tie, right? If 2 people have the same score, you can even tie for first in some cases, and it kind of depends on the tournament, but like a lot of times, especially for the big tournaments, they have a playoff, right? Or they have some kind of tiebreaker. So we got to be able to declare the winner. Maybe sometimes they have to play a whole nother round of golf. Sometimes they have to play another hole and see who scores better on that last hole or whatever, but they have tiebreakers. But in this case, Bob was the big winner. He was the only one, okay? Now, what would be helpful in some of these cases, and the reason why this is a little bit different, first place goes to Bob. And this is where it gets a little bit different. Second place went to Jim, but second place also went to Tiger. And then third place went to T-O-double-D. I got that because we went on a cruise this summer and we got kind of tired of hearing that because the cruise director's name was Todd and he went by T-O-double-D. And so every time he'd make an announcement in the morning, this is T-O-double-D on the mic this morning. We're just like, oh God, not again. But that he had a lot of energy. So if I was asking you, is this a function? What would you say? No, right? Because the 2 repeats. The x values repeat. 2 people got second place. And so we would say that this one is not a function. So it's kind of represented a little bit differently. You're going to see some scenarios like that. But the way I like to do it, and it kind of helps out, I think, is to think of it as ordered pairs. 2 went to Jim, 2 went to Tiger. So obviously that 2 repeats. So that makes that not a function. Another one that we're going to see is what we call a mapping. Mapping, we're going to have like these 2 ovals. And this essentially represents our x values. This is going to represent our y values. And so like here, we're going to have some numbers. And once again, this is going to be a little bit different, but let's just say I went 5 and 6. And what I'm going to do is I'm going to draw arrows to what each of these x values corresponds to. And as I think about what my ordered pairs would be here, 1 goes to 5. 1 would be my input, 5 would be my output. When I plug in 2, I get 5. When I plug in 3, I get 6. When I plug in 4, I get 6. Okay? So as I write out the ordered pairs, and I mean, is that something you have to do? Not necessarily, but what you're looking at here is all of the x values only have one arrow leaving from them, right? 1 goes to 5, 1 doesn't go to anything else. Same thing for 2, 3, and 4. So the y values repeat, but the x values don't. So we would say, yes, this is a function. Okay, if I gave you another one here, I'm not doing a very good job of drawing my lines here. Okay, right away, and I don't even necessarily care what 3 and 4 go to. I could say 3 goes to 6, and I could say 4 goes to 6. Okay, in this case right here, we have 2 arrows leaving from 2. So that means 2 goes to 5, but 2 also goes to 6. So if 2 goes to 2 different y values and the 2 repeats, then we would say this is no. Because 2 goes to 5 and 2 goes to 6 also. That x value repeats. Okay, so it kind of depends on where your arrows are at and what number they are matching to or mapping to. We call that a mapping. Okay, I'm not going to list out like a set of ordered pairs. Listing out a set of ordered pairs should be pretty easy. All you got to do is look at your x values and determine, are all the x values different or are any of them the same? Okay. Now we're going to look at what we call function notation. This is what function notation is going to look like. And typically we'll use F for function, just the letter we tend to use, but it doesn't have to be F, right? It could be G of X, H of X. We could use any letter we want to. Sometimes it might be a story problem, so maybe you use a letter that represents whatever the story problem is talking about. Like for C, for cost of something, you might use C to represent the cost, whatever it's going to be. So this is a function. This is no different than this. It's just a different way of writing it, okay? Y and f of x are the same thing. They are represented the same way. So you might say, well, why don't we just stick with y equals negative 5x plus 3? Well, because now when we start evaluating a function, and I ask you to evaluate this function, I'm going to ask you to evaluate it multiple times, okay? Not just for one value or 2 values, but maybe 3 or 4 values. And so it's going to be a whole lot easier than if I don't want to make like a big table of values and say, these are the numbers that we want to plug in. I'm going to say, let's evaluate f of 4. And what this simply means is we're going to take 4 and we're going to plug it in to the f function. And the f function is this function right here. So the 4 replaces the x. So in place of x, we're going to put in a 4. And so we're going to say this is negative 5 times 4 plus 3. Negative 5 times 4 is negative 20. Negative 20 plus 3 is negative 17. And if I needed to, and we don't do this a lot of times, but when I make my table of values here, instead of an XY table, sometimes you'll see it as an f of x table. So if I plug in 4, I get negative 17. So it's just like coming up with some ordered pairs, right? Coming up with some values that represent that particular function that we have. And I could keep doing it, right? I could do it as many times as I want to. Negative 5 times negative 2 plus 3 would be 10 plus 3, which is 13. So when I plug in negative 2, I get positive 13. And I could go in and I could plug any number I want to in. And so then we just say, let's evaluate it at whatever value. And so it's just a really quick and easy way of saying, let's evaluate this function at this number. Okay? And that's why we use this terminology. That's why we use function notation. Rather than having to write out that big long sentence and said, let's evaluate this equation for all values of x, and then they list out the values of x. This is just a really simple way of stating that. Now, one that's a little bit different, we can also evaluate for a variable. Okay, and if I said, what is f of n, that means we're going to, instead of plugging in a number, we're going to plug in a variable. The variable n is going to replace the x just like the numbers did. And so when I plug this one in, it would become negative 5n plus 3. What else can I do? Can I combine those two together? Make it negative 2n? Nope, they're not alike, right? We can't combine like terms. So that is as far as we can go. If I plug in a variable, my answer is going to be an expression of some kind. It's not going to be a number like we got here and here. So you'll see that a little bit today. Okay, this function here is going to be a little bit different. Because we have a fraction. Okay, we have a division sign. And we're going to do this. We're going to evaluate f of 0, f of 2, f of negative 3, and f of m. Okay, so there is a fraction. The other thing you'll notice here is that we have a variable in two different spots. So when I plug that number in, whatever number it is that I'm plugging in, or a variable, and like the case of the last one, I plug it in wherever there's an x. Okay, and so in this case, I'm going to plug 0 in for x. So this would become 0 minus 2 over 0 plus 3, which is negative 2 over 3. And we can't do anything to reduce that, so that becomes our answer, negative 2 over 3. Okay, if I do 2, this would be 2 minus 2 over 2 plus 3, which is 0 over 5, which is 0. If 0 is on top, 0 divided by anything is always 0. Okay, for the next one, we would do negative 3 minus 2 over negative 3 plus 3. And what happens when 0 is on bottom? It's undefined. Good. We can never, ever divide by 0. And if you can't remember that, or if you don't remember that, just try putting it into the calculator, right? If you try taking negative 5 divided by 0, it does not give you 0, guys. You cannot divide by 0. If 0 is on top, my answer is 0. If 0 is on bottom, that's a completely different scenario. You can't divide by 0. Okay, and then for the last one here, Is there anything that we can do to simplify this expression? Would it be okay for me to knock the m's out? How many think, yeah, let's knock those m's out? Yeah? A couple yeses? Nos? Okay? See a lot of people that say, I don't care, Mr. Ruda. I'm not voting this morning. It's Monday. I'm not voting. I'm not raising my hand. Yes or no? What do you guys think? I saw some yeses, I saw some nos. It was about 50-50. Taylor, what do you think? Can we knock those ends out?
Yeah, I don't know.
Just go for it, knock them out? Ryler?
Yeah.
Yeah? No? I saw a no. Okay. Here is the big difference, guys. Okay? If I did this, would it be okay to knock the m's out? Yes. Okay? Because there's no plus or minus signs. So that would just leave me 3 over 5. But if I do 3 plus m over 5 plus m, we cannot knock those m's out. So if you have plus or minus signs connected to that m, they're connected, right? In order to knock this out, the entire expression has to be the exact same thing. So 3 plus m, I would need another 3 plus m, and then I can knock the entire thing out. But in this case, you cannot just knock these m's out because of the plus sign, okay? That's really important. A minus sign would do the same thing. So in this case here, we would say, that's it. That's all we can do, okay? And I say that because that is a very, very common thing that you're going to see, okay? And I see it a lot, that people just see an M on top and an M on bottom. Boom, let's get rid of those because I want to simplify this thing as much as I can. But you can't. That does not simplify. And it's all because of the minus sign or the plus sign that's there. Okay. I'm going to give you a couple of functions here. And one of the other topics today that we talked about at the beginning is domain and range. Okay, and domain and range is going to be a topic that we're going to see a lot as we move forward. But in this case here, we're trying to figure out what values of x would be good here. Okay, what values of y would be okay. And I'm going to show you a really easy way that you can do this. And probably the best way to do this is to graph it. Okay, and I'll show you how to look at the graph. Now, if we were to graph this one, and you could put it in the calculator. I don't have a problem with that. But I'm just going to go up 1, make a point. I'm going to go up 3 and over 1. And this is a linear function. It's going to make a line. Okay, and what we have to remember here is my x value goes left to right, my y value goes up and down. Okay? So when I think of domain, domain represents x values. So as I move, notice this one is going to keep going down forever, it's going to keep going to the right forever. As this graph moves left to right, is there ever a time where I'm going to touch more than one point? No. So that's what makes it a function, right? But now we want to determine what the domain is. As I go from left to right, is there any stopping of this graph? No. Okay? It's going to continue going to the left, it's going to continue going to the right forever, in both directions. So what we would say here for our domain, there's a lot of different ways that we could say it. All reals would be one way to do it. The symbol for all reals is that guy right there, R with a line through it. Or if we do our good old interval notation that we've used a little bit this year, we would say negative infinity to positive infinity. It keeps going in both directions forever. Okay, what about range? Well, range is y values. Range is up and down. Domain goes this way, range goes this way. So how far down is this graph going to go? Is it ever going to stop? No, it's going to go down forever. What about going up? It's going to keep going up, right? It's going to keep going up and up and up forever. So same thing here. So anytime you have a linear function that has a slope to it, because if it was zero slope or undefined slope, that would change things. But if it has a slope to it, your domain and range will always be all reals, every time. Let's look at another one. Let's do f of x equals x squared minus 4. Okay. And there's a couple of different ways that we could go about this. But if I wanted to come up with the domain and range. Morning.
Morning.
Once again, best way to do this would be to do a graph, okay? And can you use your calculator to help you come up with a graph here? Of course, why not, right? And you've got a tool to use, why not use it? And so what I would do here is I would go, but I just wanted to show you where you could come up with this. If you need to get some ordered pairs, just to kind of see what's going on here. So this graph looks like this. And the purpose of this is not to graph it, so we don't need to get real specific with our points or anything like that. We're just using a sketch of this to help us identify the domain and the range. Okay? So, domain. How far left and right is this graph going to extend? Forever, right? Because as this one keeps going up, it's going to keep going to the left as well. As this one keeps going up, it's going to keep going to the right. Okay, and it may not be getting there very fast, but it's going to keep moving to the right. I could plug in 100 for x, and I could get a value. I could plug in 1,000,000 if I wanted to for x, and I would get a value, right? Whatever I plug in for x, I'm going to get a y value back for it. And all of my x values are going to be different. I can plug in whatever x I want. So once again, we're going to say negative infinity to infinity, or all reals. I don't care which way you express it. It doesn't really matter to me unless it says express your answer in interval notation. It's going to be something that we keep seeing from time to time. And obviously, that's been a big topic that we've seen throughout the semester so far. Okay, now range. How far down, when I go vertically, how far down does this graph go? Does it keep going down forever? -4 is the lowest it gets, right? How far up is it going to go? Infinity, right? It's going to keep going up to infinity. So when I write my range here, I would say -4 to infinity. Notice that I'm using a bracket here. A bracket means we're including -4. We're starting at -4. We have a point at -4. That's my first point, and it goes up from there. If I wanted to, I could use y is greater than or equal to -4. It means the same thing. It's talking about all of our y values have to be greater than or equal to -4. This is probably the way that you would have wrote your range when you were in Algebra 2, okay? Now we're going to start seeing interval notation more often. They both mean the same thing, but just know sometimes it may ask you to give you answer in interval notation. Okay, the last thing I'm going to show you here. You have a problem like this today. And this is kind of a different way of asking you this question. We already asked this question earlier in the lesson. But when I asked you earlier, we were given an equation or a function, right? And it said, okay, here's the equation. So all we had to do was take 0, plug it into the equation, and we got our y value, right? Well, we don't have an equation here. All we have is some ordered pairs. So we need to figure out what y value is going to be associated with an x value of 0. So all we got to do is look at the ordered pairs, right? So if I were to plug 0 in for x, what do you think the y value would be? How come? Chloe, what do you think?
The dot.
Yeah, the dot, right? Because right here is the ordered pair 0, 1. So when x is 0, my y value is 1. So this ordered pair right here is identified as 0, 1. So we're just going to say f of 0 equals 1, right? Because that's where the point is. We're going to go where x is 0. We're going to see where the point is that matches up with that. And we're going to identify the y value. So if I go to 3, I'm going to go over 3 and up 2. So my order pair would be 3, 2. When I plug 3 in for x, 2 would be my solution. Okay? So it's just kind of another way of understanding how the evaluation works, but we can do it without an equation as well. Sometimes I'll be given an equation, sometimes I might just be given the graph. You're going to be given functions in lots of different formats today. That's why we talked about the table and the mapping and the graph, all of those different things. Okay, that's all we got. It's today's lesson. Chapter 3 is done. Okay, we're going 6 to 66 by 4. So we're starting on number 6. Every fourth one. So 10 would be the next one, and then 14, and so on. Pay attention to your instructions. When you get to problems like number 18, it says find the domain and range. When you write your interval notation, I think I wrote my answer in interval notation. So as you check your answer, that's the way I wrote it. You could also write it other ways as well. So it's kind of up to you how you want to do that. Okay, I guess we're about